All right, well, welcome. This is the group TRIG, the Technology Research Interdisciplinary Group, and we talk about different things related to human augmentation and the relationship between humans and technology. And this series, what we've been exploring is this topic of synesthesia. So the first few videos that we had done was like the introduction into what synesthesia is, how do you categorize it, how do you test for it, what are the different causes of synesthesia, things like that. Can you acquire synesthesia? If you don't have synesthesia through training, can you get it? So we sort of explored some of those concepts in the last few videos. And I thought in this video, we'd focus more on like devices that people have made to give individuals experiences like synesthesia. And so today what I'll do is go over a PhD thesis that I found online, and it's from the MIT Media Lab. And so I'll just scroll through it and I'll just share the ideas, and then we'll do our usual brainstorming session at the end. So let me share screen here, share. And okay, so here it is. It's called Digital Synesthesia Using Mobile Technology and Sensory Substitution to Interact with our world. I mean, already it's kind of interesting because in our last discussion, we sort of tried to look at the difference between, synesthesia and sensory substitution. And it seemed that some review papers were saying, look, these are actually two different concepts. Sensory substitution is the idea that you take a device and it helps you replace a sensory system that may not be working. So for example, maybe you're blind, so you'll replace what you see through vibrations, and so you're replacing like a sensory system. Whereas synesthesia is more, what this review paper was saying is more about sort of overlaying more information on a sensory system that's existing and sort of working. So, but I don't know. I mean, I think the literature has some sort of debate on that. Let's see, let me actually move this people panel here. Okay, so I'm just going to scroll through it. It's 177 page, it's 117 pages. So this device he's trying to create, digital synesthesia, is what he's saying is the concept of using sensors and cell phones, mobile technology to create like a user experience that will mimic the way people use their senses and enables a perception of information that is outside of our sensory spectrum. So, this does sound sort of like a synesthesia type thing. You're sort of, enhancing what humans can otherwise experience. And I'll just, keep scrolling until I see some highlighted spots. This thesis was actually kind of interesting in the sense that there was some interesting, imagery there too. So let's see, that's okay. I'm just going to keep scrolling. And I'll keep scrolling. And we're going to get into. So, this person explored a few different things. One of the things that he explored was expressing information, I believe, through temperature. And so he had these little things that could provide temperature. And the second thing he sort of explored were vibrotactors, which we're sort of familiar with, these vibrators that are placed on the body. And both of these that you're seeing are not the ones that he actually used. I think he's just going over the literature right now. One interesting thing, so this is not what he did, this is in his background material, but I thought it was kind of interesting. Some of you that were here for the last iteration of this TRIG thing, we looked at sensory substitution, and the device that we made based off of literature that people had done, many decades ago was something similar to this, which is that you had, like something that detects light, and then it was attached to a vibrator. And that's essentially what they've created here. But what these people did that brought it to the next level is that it sort of could really, sense like projected light so that you could, for example, be going down this like really detailed figure and feel things. So we did not do that. We actually explored more individual differences in feeling like you're merged with the device. Okay, let's see. This was also interesting. Again, this is not stuff he did, but he was just talking about this stuff. So here what they did is they had two cell phones, right? So it could be your friend has a cell phone and you have a cell phone. And then like, you could record through the skin the arousal level of the person, the more aroused the person got. And by aroused, I mean like, like agitated or stressed or, anything of that nature. That would then convert to like, vibrations that a person would feel on their phone, that your friend would feel. So it's like your friend is feeling vibrations on the phone that's indicating your like arousal level as detected by passing a small current through your skin. I mean, it was kind of an interesting idea. And then, a similar sort of idea they had was that, if your friend is like really like squeezing the phone hard, then you begin to experience that. So you can kind of experience how your friend is interacting with the phone. So I don't know. It was an interesting sort of concept. And he talked a little bit about the sensory substitution devices in his background material. And this, I think we're familiar with. I've talked about this. They sort of had a 12 by 12 grid, and you put it on your tongue, and you attach it to like a movie camera, and you're able to sort of like, the movie camera sees like an X, then you get an X-shaped shot on your tongue, and you can kind of feel objects and things like that. This was also kind of interesting in his background, which I thought was cool. This artist, Neil Harbinson, developed this thing called an eye board. I feel like I had heard about it, but I'm not in detail, so maybe we can read this paper at some point. This artist is completely colorblind, and he uses this device to capture color information through a camera on his forehead, and then translates it to sound that he hears through sort of bone conduction. So, very different than your idea, Janet, but, it has something to do with color. So I thought maybe you'd be kind of interested in that. Okay. This one we talked about. I had done this in the first sort of iteration of TRIG. And, this is like, they had this like, and I've talked about it a few times, this belt that has vibrotactors that would always indicate north. And it's kind of interesting. And it was also kind of like a bummer in the sense that like the authors were hoping that if you like have someone wear this for like a week or two or whatever, they'll sort of gain like a sense of where north is. But they really did not find anything like that, and sort of went to make people think deeply about like what is the extent of these devices, and in what situations do you really bind with it, and what situations do you not. The other sort of things that he talked about is, I think this one people may have be familiar with. I actually met a person, and she had this, and I met her randomly. She was a roommate of one of my friends. But this guy, he implanted a small magnet, just surgically just stuck a magnet in his finger. And like the person, my friend's roommate, I think she just did it herself. Like she didn't even go to the doctor. So you, so you can just cut yourself and stick a magnet in there. And apparently what they report is that they can kind of sense electric flow. Again, like it's not like you'll be going on in like normal life, you'd be like, whoa, I feel electricity everywhere. It's more like, I think if you go maybe underneath an electrical line or somewhere where there's a strong electric field, perhaps, then you can kind of feel some sort of sensation. But it is kind of interesting, that kind of idea. Okay, so let's see next. Yeah, the other kind of interesting idea that he talked about that we should think about as we're developing stuff is he gave, the individuals the ability to sort of map the sensitivity. So for example, one of the things he does, which I'll talk about later, is he just put like a motion sensor on your finger so you could sort of detect how far away something is, and it would sort of indicate through vibrations. And so he'll let the people sort of adjust the magnitude of those vibrations, I think, or maybe he was adjusting it, but I think the main thing was that this is something that we should think about, like how hard, what the sensitivity is of the information that we're sort of providing. Okay. So yeah, so these are the things that he actually did. It was kind of interesting too. So he had 3 studies. During the first study, users would be able to try the new artificial sense that would provide a redundancy with an existing natural sense. So, you could be the distance sensor, you see the distance and you feel the distance. And then the second one, they designed to take away the redundancy, but still give the user some contextual information. And the third one, you removed all redundancies in contextual information and simply asked the users to explore the world and understand it. So you don't even tell them what the device does. It's just like, here, take it and explore. It was interesting. It's an interesting concept. So the first study he did is he gave people just a distance sensor, and I don't think, Janet, you were there. Maybe you were, maybe you were not, I forget. But like with Jacob, we actually built this. Like, we just put for the Waltham High School students when we were doing like the human augmentation thing. We gave the students like these ultrasonic like distance sensors. And basically what it does is it sends out like a ultrasonic signal, and then it echoes back, and then the device is able to calculate how far away something is. And they're accurate, but not like super accurate. And they get messed up by, you can imagine, like very shiny, mirrory surfaces and stuff like that. He probably has a more advanced version of it, but still, I mean, the cool thing is that we brainstormed some of these ideas. So he gave proximity sensors to wear on the palm of the hand, and then you just felt a vibration. And, the distance was sort of expressed through like the frequency of vibration. I mean, this is exactly what we had actually done with Waltham High School, which is kind of cool. And so they did that. They also had like sort of identifying different shapes. So he had like a square, a triangle, a circle, and you sort of had to use a distance thing to sort of figure out like what the shape is while you're blindfolded. And then they also had 3D shapes. And in the second sort of study, what they did is the person had like a headband that had a temperature sensor facing outward. So you had like an infrared, it could sort of detect temperature outwards, and then it would vibrate on your forehead, the temperature roughly. So, he put like 4 like heating modules, like these produce heat, on a table, and then the person had to sort of figure out like which one is the hottest. And they had vision and stuff, but like, visually they were getting no information. They couldn't touch it. They could just look at it and try to figure out which one is the hottest. And the final study was, a little bit wild or interesting in a sense. So what they did is that they, the cell phone came with many different measures, like, and I think he listed somewhere, but many different sensors, right? Like your cell phone has like, detect tilt and acceleration and velocity, whatever, anything that your cell phone can detect. They would sort of randomly assign that, okay, this is going to become a light detector. And it's going to, express that through vibrations. But the person did not know which of their cell phone sensors was indicating the vibration. So they basically just had to take the cell phone, walk around the lab, and figure out, which sensor they thought was being activated. So those are the 3 studies that this person did. And let's see. I think there's some results. What else? I guess he did some smell stuff too. Which I think I'll describe as I scroll down. Okay, so yeah, the proximity to vibration. This one, let's see. Here's like the proximity sensor. Got some circuit stuff. We had done everything through Arduino. It looks like he custom made a whole bunch of stuff, which makes sense. And here it looks like here's a proximity sensor, and you've got like the vibrations and stuff. And this is it, exercise done 4 times, varying the height of the objects, and you're just trying to like determine sort of like, maybe how high it is. And then, he's got like percent accuracy here, and just seeing that, okay, these people are kind of accurate with this thing. And that's in many ways most of what happened. And then he had people try to identify shapes. And again, he found that, they're a little bit, for the circle, for example, or the rectangle, they're below chance. But for other things like the triangle, they're above. So, it's kind of effective, kind of not. And they did it with 3D objects to see if the person, could identify a cube, a sphere, pyramid, or whatever the 3-dimensional triangle is called, prism, or what's it called? Prism. And again, you can see some things are low accuracy, some things are high accuracy. Okay, so these are some of the studies. Of course, you had to normalize the sensors, and we can just skip through some of this. It isn't, interesting. Temperature to sound. Um, uh, Artificial, let's see. We're almost through, just I think, yeah, this is the one where you've got like 3 heating objects, and then you got to figure out which one is the hottest. And he found that people can kind of do that, and then as they get more and more practice, they get better at it. So 80% accuracy. Okay. Let's see. There's one more. Oh yeah, and then he had like his cell sensors to sound. And I think he has a list of the different sensors. But long story short, so your cell phone, they had all of these different sensors on it. I guess not all the phones had everything. And long story short, I think he found that they weren't very correct in sort of figuring out what exactly was being expressed. And then this was actually kind of interesting, just in the sense, and maybe more just like the concept than the actual experiment. But I guess the media lab has a food camp. So like, if you have like leftover food, there's a camera and it takes a picture of it, and then it sort of emails it to people in the lab to let them know that there's free food there. So I thought that was kind of interesting. And all this guy did is then connect this to like like an Airwick dispenser, so he could smell when the food was there. And he found the experience to be useful. And then I guess he tried some stuff with the smell mixer, but I don't think he had like significant data there. And then he tried stress to sound. So, the idea is that like if you're playing poker or whatever, theoretically, there's small changes to a person's facial temperature. And if you can detect those small changes, then you can sort of maybe detect the person's mental state. You can predict whether they're going to win or lose. So here he's got a bunch of people playing poker, and this person has the infrared sensor pointing right, at her face, recording, I guess the micro changes in her temperature. And then they're all playing poker and they're getting feedback on I guess her face and the temperature changes there. And long story short, it wasn't useful. And so he hypothesized a bunch of reasons why, but let's see, anything else? But this is the summary, proximity to vibration. People were able to learn very quickly and identify the objects with reasonable accuracy rate. The ability to confirm their guesses greatly increased the learning curve. Changing the sensitivity does affect the outcome, and the users report an understanding of how it works. Objects may have peculiar signatures that would be difficult to predict or easy to identify and learn. This is actually kind of interesting, this point here. So what he said is that, like, I think that the prism or the sphere, one of them, it wasn't intuitive when they're using the distance sensor to sort of be like, oh, okay, this is what it is. But what they discovered was that it had like a particular feel to it. And so then they were like, oh, this feel I associate with the prism. And then they were able to recognize it. So it's kind of cool, like there's like an abstract feel, but then they were able to essentially be like, oh, that's a prism. So maybe that was kind of cool. Temperature to sound, users were able to quickly understand the patterns, but have a hard time aligning the sensors to the device. Okay. Offering feedback to tell the users if they're correct or not only help the learning, so okay, good feedback is important. Okay, and again, it goes on like this, get a sense of it. And I think that's pretty much it. Okay, so that's the thesis, and I'll get the flowchart ready, and then we can do some brainstorming. Let me just maybe you guys can say some stuff while I'm finding this flowchart app. Any thoughts?
The very first thought I had was just the sensory substitution versus synesthesia thing, you know? So I think standing alone, like they're pretty separate, but when we're thinking of devices to train people, I haven't looked into it, so I don't know, but like my opinion is that it starts off as sensory substitution, then develops into synesthesia because, you know, you gotta learn it. So I think there's like I think it can turn into synesthesia, but they're both still separate.
Yeah, it's a really cool point because, oh, I got the app ready. Oh, let me see if I can expand. Um, let's see. Can you guys see your faces?
Not on
Um,
on your screen. I don't
oh, not on
think.
my screen. Okay, I don't know. I can see.
See
So let's just,
mine, like on
yeah.
the side.
Um, so yeah, let's put that in. So like, sensory stuff. Yeah, I mean, it's kind of interesting because it depends what sensory system you have. So like if you're blind and you've got like a sensory substitution device, I don't think that would, but in this situation, if you've got sort of like proximity and vision, you're right. Like maybe it starts off as one and then transitions into another one. Um, it's kind of interesting. Like I guess where the territory of sensory substitution and synesthesia exist is unknown, and there probably are some overlap spaces. Yeah.
I noticed something when towards the end, you brought up the point about some shapes like a prism being sort of easy to identify, but they couldn't really like describe it, I guess. Makes me think there's a factor of like memorization and not really sensing.
Yeah, this is a really good point. Like the signature field
Mhm.
um, suggests memorization rather than
Sensation, really.
sensation. Yeah, yeah, it's a very good point.
Thank you.
And it's kind of related to some of the other things that we were looking at because like with the paper that we had done on the training, where like people were trained to elicit colors that they saw around them, they tried to go to certain lengths to make sure that it wasn't just memorization that they were doing. Oh, red means this particular note or whatever, but rather they tried to randomize it to a certain extent so that people couldn't just memorize it. So it's kind of interesting. This kind of goes back to the point, like, what's the difference between memorization and actual association? Um, difference between memorization and like, I don't know, sensation association. It's a pretty deep thing.
And just adding on to that, would people say they're merged with the machine even if they're just doing memorization instead of sensation? It might be interesting to see how they describe it and if it's different.
That's a great point, yeah, do people's, what is the perceptual experience for memorization versus sensation? And to a certain extent, this also connects a little bit to, Janet's point too, because like it's sort of like, is there a perceptual difference between sensory substitution and synesthesia, or not? It's with sensory substitution with the brain port and stuff like that, some people have this, phenomenological or whatever the word is, like, this actual feeling like they can see now, even though they're blind and they've got these tongue shocks. Some people are like, oh, I can kind of see again. Whereas with synesthesia, at least people who naturally have it, they will always sort of report being able to perceptually feel something. It's not memorization based. So again, synesthesia may be that you naturally have it and that connection is there. And sensory substitution may be for those individuals that don't have it to acquire something that gets closer to associating something that typically is not associated. It could be something like that.
I think the point of the importance of sensitivity for the device was really interesting too. I'm interested in like sensitivity differences in age groups too, because as you grow older, your sensory system might decline. When you're younger, you're really, hyper aware of everything. But I mean, of course, also for like the quality of the experience the person is having, it's important to have good sensitivity. But also going off of like the perceptual experience too, I wonder, people who have an easier time merging with devices might need the sensitivity to be lower, higher. Yeah.
It's really, I mean, I also, the aging thing is a really great point. You mean just even studying, how does sensitivity ranges change as you age? I think would be really fascinating. It would not be, as straightforward as just that you get older, the sensitivity decreases, so you need higher information. Because, more than that, what's interesting is like the content probably would also have to change so that it's like something that people can understand better. But like with autism too, like some children or adults that have autism are very sensitive to sensory information, and so decreasing that would be important.
With these tips, that made me think. Sorry.
No, please.
It's interesting, like with the example of autism, because I've looked into like sensory like substitution and all of that with autism, and you would think that like having less stimulation is good, but in some cases it's better to have like to feel enclosed. You don't have like something else stimulating you, so it could go both ways. It's really interesting to look at. I feel like these devices can really work both ways for a lot of demographics.
That's really deep. What sensations convey safety versus irritation? It's kind of interesting because like, a vibration would probably be something negative if I had to guess for someone who's autistic. The reason I say it, not even with autistic, even with children, so the lab I'm in, at one point they were looking at sort of like, reaching movements in children. And these were not even autistic children. And what we had to do was put like motion sensors on their hands so that when they reached, we could sort of get like a sense of what's happening. And these kids were like kind of freaking out. Like they were like, I don't want this on me. And I was like, whoa, it's like, so like it was kind of really fascinating to see like in them. And I think with autistic people, it may be even heightened to have these things. But at the same time, Janet, you're right. Like something that sort of shelters your, like a weighted blanket or something, may actually be really good. So I mean, if you're designing sensory substitution or synesthesia, tapping into that would be huge. And it's something that I think we haven't really thought about, that much, or the community hasn't thought about it. So it's a really cool idea. Yeah.
If it's okay, I want to bounce off of that because I actually tutored and worked with students with learning differences. And so accessibility, I guess, played a big part of that, main part of that really. And similar to like sensations conveying safety, I guess colors kind of have a similar impact with not necessarily conveying safety, but more so colors that people, would see better or like preferred. And I guess it's somewhat like conveying comfort in a way with specific colors. And so I wonder if like a sensation and a color in that regard may be tied. Not too sure where I'm going with this, but kind of like color as opposed to sensation conveying an emotion.
It's a really great point, Yara, and it also connects to the idea that Jan was talking about a little bit with her own thing with identifying colors. But that's something I had not known. So I appreciate, Yara, that you brought it up, that colors can have like a big role for certain people, and as opposed to sensations too, because I think you're right. Like sometimes we overemphasize sensations, whereas there's a rich world of things outside of just sensations that we should explore. So that's a really deep point.
And I guess even with like my own day-to-day experience, I tend to also associate certain colors with, I guess, a place or a mood or something. Kind of like mood rings that change color with how you feel. Just like certain people tend to associate colors with feelings generally.
I think, and one of the most common types of synesthesia is color related. So it is kind of, this connects to, color graphemes and color synesthesia as well. So I wonder if there's some sort of connection like that too.
What's interesting with color too is like, I think obviously there's like a societal impact to like, we just come to know a color associated with an emotion. But I think there really is a biological one too, like what favors our eye, like our eye likes the color green and like light blues more than like intense neon or like red, So I think it's cool to look at that too.
Yeah, what do they call it? Nurture versus nature? Is that what nurture?
Yeah.
Interesting point, because while it might not be like a tangible comfort with certain colors, I think we're more subconsciously accepting or like willing to, I guess, more perceptual when certain colors are used.
It's really interesting, like like how far can we sort of go with this, and can we like sort of nudge people into different like states and things like that, and how much can we override it with our brains? I mean, I remember like some sports locker rooms or whatever will make like the walls a different color, so like their opponents are maybe not in like the right mood, but does that really like affect a person or not? Or it could also be like in moments of like weakness or tragedy or like trauma, that's when the colors matter. That's when they trigger things to you, and so you may not realize that that's a trigger that exists, and it may be something important to think about. That's a really interesting. So these are, like all the PTSD and all that stuff are essentially associations. So.
And I suppose a big part of that would also be like learning or association that's taught, like the way we associate green with like the right thing and red with the wrong thing. And it's part of it is like subconscious, but another part is just actual learning, because it's, we're taught that it's supposed to be that way, but is it?
So what, do you guys have, ideas for devices, like as you were hearing this, that you were like, oh, we could build something based off of this or enhance it or whatever? Any new ideas that you guys haven't shared that maybe was motivated?
I think I think it would be interesting to consider sort of the different, like if we build some sort of device that would interface what we saw on our screen with maybe some sort of device that either provides sort of some low scale vibrations or some sort of either like degrees of unpleasant feelings, and sort of seeing if we can, just before we even get into synesthesia, seeing if we can build sort of these associations or break the associations we already have, like maybe more biologically, and see if, I don't know, if we see a certain color, feel a certain vibration, like can we train ourselves to like that color more or less? And then I don't know, it's not very developed, but
no, I mean, this is the perfect thing for this sort of brainstorming. You're not supposed to have developed ideas now, because it's supposed to, it's supposed to be like you just take everything and you just put it on. So I appreciate that. And I think it's a really cool thing. I mean, to a certain extent, Erica, she developed the app, which was like a first like exploration into looking at the screen, and they were not vibrations, but you had sound and stuff like that. So it is kind of interesting to begin exploring like novelty using our computer screens, which are magical portals, and we can do so many different things with it, and see what kind of sensory experiences we can induce in ourselves.
I think that's such a great idea, and I'm sure this is like inspired by what we've already done, but I wonder if there's a way to like, after pairing a color with the visual stimulus, sort of randomize it and then kind of test ourselves, or like see, if we made that association or if we're reforming a new association. Yeah, just somewhere on there.
Yeah, I think it's a great idea. You know, the other thing I was gonna say, oh, Janet, were you gonna say something?
I have a thought I can share if you want, yeah. I was thinking too, just like you're saying, like at first we have it on the phone. I'm thinking in a classroom setting, kind of like what if everyone, on their own time is practicing on their phone,
Mm.
and then the slides of the PowerPoint are those colors, and then kind
Yeah.
of like do something there to see how the associations ended up being for those students.
And for those of you that may have missed it, Janet had a very epic PowerPoint on this. And so, you know, we as we start building our devices, maybe we'll go into that. The other thing that I wanted to say that maybe connects a little bit to Janet's and maybe goes a little bit off into outer space, is sort of like, you know, part of what I've been exploring sort of in my, I don't know, creative personal life is, you know, these like novel experiences, for lack of better words, you could sort of almost say like, you know, the shamanistic, you know, sort of like, uh, you know, shamanistic like procedure for making people feel connected. I mean, if you think about it, back in the old days, each culture had their own shaman or like person who connected to the vastness, and right, the witch doctor, whatever you want to call them, right? And they did play a role because like the placebo effect and things like these have shown that if you really believe what's happening, you can reduce your levels of pain or your levels of stress. You know, like these large things actually are affected by belief. So long story short, I mean, are there things that shamans did to make people believe what they were doing really will reduce their pain, and therefore they actually reduce their pain? Can we exploit some of those things to now build these associations with these technology things that we're looking at? That might be kind of cool to sort of explore at some point too. And you know, since I do a lot of events at my house, so like, you know, that could be one interesting event. Actually, in a few months, I will be doing an event. And if any of you want to collaborate on this, it's probably in like 2 or 3 months, on building, how do people build bridges between their subconscious and conscious minds? I probably told you that already, but like, you know, I'll have a little bit of like literature, like I usually do, like, you know, science literature, whatever, academic stuff, and then some artwork and then some ceremonial stuff. But it may kind of fit into what we're talking about here as well. You know, can technology play that role or not? And I think that we've all sort of shared ideas similar to that. Yeah.
I was watching a video today of someone who has mirror touch synesthesia. And it's
Oh, what's
basically
that?
anything that they see someone else is doing, they experience. So it's like, if like, and that's what actually when you were showing the paper and the kind of like the poker game and like detecting, someone like being stressed out over like their hand or something, people with mirror touch synesthesia can pick up on these little things and just they experience it themselves. This one lady in particular, the video I was watching, she unfortunately is like senses pain a lot. So like if she sees someone with a broken arm, she feels like her arm is broken. She is a
Right.
massage therapist though. So she actually is like, anyone that comes in and say they like complain of like shoulder pain, like she feels that herself. So it actually like helps her at her job because she tries to think of like what would help her,
It's kind of interesting because, like, you know, in the I haven't followed it in a while, but in the, you know, neuroscience literature, you do have like, you know, you guys have probably heard of the mirror neurons. And they're contested. You know, not everyone is like a fan of it, but I think something of that nature does exist. And so the mirror neurons, the basic idea, as you were saying, is that, you know, they'll find that the brain activates when someone else is eating food or someone else is doing stuff. And these are important for us to be able to learn how to do things that other people are doing, and also important for us to be able to empathize with what another person is going through. So you could imagine that this sort of thing, if it was sort of like really pulled up, then you may actually not only sort of like feel it dull, like an adult sense, but you'd actually vibrantly feel it. You know, I mean, I think we've all experienced when we're hungry, if someone else is eating something, then we begin to salivate and stuff like that. So in a way, we may all have some sort of experience similar to that. It's kind of interesting.
Yeah, I don't really have like my own device ideas, but like when you were talking about the paper and the different experiments that he did, like the magnet, the invasively putting the magnet, there's like non-invasive ways, like nail polish. There's like magnetic nail polish that we could try out, all of us, if we wanted. So that's like an easy way to test that out.
right.
And
You
then
know,
yeah.
I
Oh, go
I
ahead.
was just gonna say when I met the neighbor and stuff of my friend, I was like, man, like instead of surgically, like you could almost just tape a magnet onto you or like right, like why is it surgically implanted? But yeah, you're right. So yeah.
Yeah. And then for the infrared experiment, I thought that'd be so useful for firefighters, like if they're going into a house, like to be able to already know where the fire is before going in, you know.
That's
be
really
able
all.
to
That's a great idea.
And that too could be the thermal detector, the thermal experiment as well. So it could be thermal and infrared. That'd be so good for firefighters.
Yeah, you know, like I wonder why they don't have like maybe because it just obscures too much vision. That's why they can't have like the actual thermal cameras and stuff like that. But like if you can feel it on your body or something, maybe that is something that would be that's a really cool idea. Let me capture it right here. That's really cool. Yeah. Connected to mood ring, certainly. That's a great idea. All right. Any other? We have come close to the end. Any other last ideas? Chat here. Oh yeah. Cool. Yara have to go. No probs. All right. Well, I mean, this was a really good brainstorm session. Let me stop recording. Stop recording.